Open up the door, it's Dave! Who?
Hey everyone, it's Dave. Welcome to another edition of Just What Do You Think You're Doing, Dave? I wanted to talk a little bit about the sun and its position. Have you ever noticed when you go outside, you see shadows on the ground? You may go to the bus stop every day or to get coffee every day, and you walk outside and you see that the shadows are on the ground, but you may notice, perhaps, that the shadows move slightly every single day. The shadow that's on the ground where the sun hits some object makes the shadow move just slightly every single day. Why is that? You can kind of think about it and kind of come up with your own experimental method for thinking about it. But I'm going to give you a little clue here. It's all because the way the sun and the earth interact with each other. The earth revolves around the sun and is tilted slightly on its axis as it moves around the sun. So as it's going around, in that period of time, you're going to see the sun actually show up in a slightly different place in the sky, which puts the shadow in a slightly different place on the ground. And this is a really fascinating thing. And if you study it for an entire year, you go out and you look at it every single day, you'll notice that the sun moves in a very unusual configuration. It moves in a figure eight in the sky. What? It moves in a figure eight in the sky, all because of the way the earth revolves around the sun, and the sun's positioning as it's going along will be a slightly different place every single day. So I've done a year's worth of video on this, and I wanted to share that with you now. What I did, I went up to the same location for an entire year. It's every about 10 days. While it's possible to do it every day, and I probably could have set up the camera to do this every day, I decided instead I would go to a local park that had a nice tree in a position so you could see the position of the sun relative to the tree and the position of the shadows on the ground. Now, I did account for the fact that there's a daylight savings time so that each of the observations was at the same time. It's important to keep that in mind. So I went out and I looked at the sun's position, and here's what I saw. And my plan is to come here maybe every 10 days or so and take a little video so we can do a time lapse of what it looks like as we revolve around the sun. So we'll be here at the same time in the same location, and you can see how the shadows are different and the sun is different. This should be interesting. What I saw, you can kind of get the sense that it's making a figure eight in the sky as you look at it. It's going around, and it comes around and goes back, and by the time I got to the end, it was back to the starting position again. If you think about it in perspective, I'm down here in South Florida, fairly near the equator, so I'm going to see a slightly different thing than you might see if you lived further north or south. Now, if I take a picture of the park and overlay each of the sun's positions that I recorded, and then draw a line that kind of connects them, you can see how it makes a figure eight. Now, the figure eight is a little bit funky looking, and that's probably because of a little bit of measurement difference. Maybe it was standing in a slightly different place, or perhaps the time was off by a couple of minutes. So you might see that it's a little wonky looking, but you get the idea. It does form a figure eight. Now, you'll also notice that on the bottom right-hand portion of it, I have more measurements. I was going out a little more frequently, like closer to every 8 days. And I've marked on there where the winter and summer solstice are, and that should give you a sense of how this all looks from my perspective. How cool is that? When you stop and think about our observable universe and something that I could just do simply by going out there and taking a picture every single day, I could see how it made a figure eight. And it is really interesting to think about how that happens and why that happens. Here's where the research in our scientific method pays off, because we can understand why it's happening. If we look at the model of the way the Earth revolves around the sun, we can see that this actually works out this way. And again, it's just because of the tilt of the Earth slightly, that's tilting toward the sun and then tilting slightly back away from the sun at different times of year, that this caused to happen. So it's really kind of a fascinating thing. And it's really neat when you stop and think about what we can see. This is something we can observe. We can actually draw a conclusion from this, that the Earth does in fact revolve around the sun. We can also make some broad inferences about the shape of the Earth, because if the Earth is tilting one way and then back the other, so that we're closer and further away from the sun, that's part of the reason that we're seeing it go in the distance and then go lower on the other end. So at different times of year, it's at different points. So that 8 is created because you're actually moving closer and farther away from the sun. And we could also make the inference that the Earth has some roundness to it, because if it weren't round, it wouldn't be tipping away and making that shape like that in the sky. It would look the same all the time. It would be like a flat line, but it's not. So we can draw some conclusions based on what we're seeing with a very simple design like this. We're just looking at the sky. We're just trying to understand what happens. And we start to see that there's more going on than meets the eye. It started off with a very simple, hey, the shadows are on the ground in a different place every day, and became something where we start to understand our world and our universe, because we understand how the Earth revolves around the sun. Now, there's more behind this. There's a lot more science you can research and learn a little bit more about, but I just wanted to share with you the very basic principle of what's going on there, so you can go out and take a look at it. And I would encourage you to go out and take a look at what you see. Spend some time and look at it. When you're going to work every day or going to school every day, go out there and take a look at where the sun is in the sky. You're probably passing by the same place every day. And when you do, just look up and see where you are. Being careful, of course, not to burn your retinas out by looking at the sun directly, but otherwise, just take some time and look at what you're seeing. And notice where the sun is in position, and look at where the shadows are on the ground. And you'll learn a little something about the observable universe. Well, that's my story, and I hope you've enjoyed it. And remember, if we can dream it, we can always do it. Bye now.
What's your point, David?